Let's do, all right, so yesterday we figured out what the limiting reactant was. Let me see if I can raise this up just a little bit. There we go, that's a little better. All right. So the limiting reactant we found was, in this problem anyway, was strontium chlorate. Okay? So now that we have the limiting reactant, we can find the other two things that you might have to find through stoichiometry. And that would be the theoretical yield and the excess reactant remaining. Okay? So let's start by finding the theoretical yield. And we're going to do that by starting with the given amount of this limiting reactant, not this calculated amount here. Okay? Now remember, we found that this was the limiting reactant because this calculated amount is more than the given amount. Okay? If you're one of those people that likes to know, well, why? Well, that's because basically you need more of this stuff. This shows you that you need more of this stuff here to completely react with all of the other reactant. Okay? And since we don't have that, that's the limiting reactant that's going to run out first. So we want to start with the given amount in the problem of that limiting reactant we identified down here. Yes, ma'am? No, you don't have to do stoichiometry twice. If what you calculate turns out to be an amount that's less than what you're given, that's the excess. It means the other reactant is the limiting. You don't have to. You've identified it either way. Okay. All right, then let's see. So we want to start with the given amount of limiting reactant. Our limiting reactant is strontium chlorate. So 5 grams. Let's see, here we go. We're going to find our theoretical yield here. Okay. And so we got 5 grams of strontium chlorate. Wait?
Yeah.
Why?
Because strontium chlorate, what's the 8.46 if you have 5 fusions?
We don't. We're done with that. Once we get this number and see that that number is greater than the amount that you're given, you know this is the limiting reactant. We don't do anything else with that number. Okay? Now, there are other ways to calculate limiting reactants or determine limiting reactants. Okay? In fact, most textbooks don't do it this way. Most of the textbooks I've seen have you do a molar amount of both reactants. So they stop with the equation right here and compare the mole ratio to the mole ratio in the balanced equation.
Yeah, that's awesome.
But right. So, but I find that a little more complex because we're doing so many mass-to-mass calculations. I'd rather you do it this way and make it a little bit simpler. What?
What is SrClO3 if it's not strontium chlorate?
It is strontium chlorate. It is also the limiting reactant. You've got 2 reactants. This is the one that limits the reaction. The reaction stops when this runs out. Remember our cookie analogy?
Yeah, if we have 5 grams of strontium chlorate, how do we magically have 8.4?
We don't have magically 8. That's the problem. It has to. This runs out first. Okay? And you might say we need this amount, and we don't have it, so this runs out first. Okay? All right. So 5 grams of strontium chlorate over 1. And we need to go to Moleville here. And we already have a molar mass calculation down here. We did that yesterday. Jay Breezy. Misha.
She's getting me off track.
Hey,
She's trying to get us to shave his leg.
Look. Shaving your legs doesn't matter. Let's do this. Okay. Shaving his head. You know what? It doesn't matter.
I don't care if it's your head. I don't care if it's your legs. I don't care if it's your arms.
Brian, this isn't even your fight. You don't have a dog in this fight, Brian. Stop.
I got a dog.
Now be quiet. Look, you don't want me to go so far as to say, everybody be quiet, I'll write you up. Really. Come on. Work with me here, please. Okay?
There. It says it right there.
All right. That's right. It says it right there.
Right there.
All right. So we have an equality statement down here. And from the equality statement, we can write the conversion unit we need. We need to match the units and species here with the units and species and whatever is left in the problem at this point. So we're going to put this number in this side of the equality statement on the bottom. 254.52 grams. And that didn't look like parentheses, but that's what it's supposed to be. And then the other side of the equality statement here goes on the top. Okay. And yes, I can hear people whistling the little tune we use. We're going to cancel as we go. Canceling units and species here. Okay, because I can do that when I have one on the bottom and one on the top, just like X's and Y's in algebra. Now that we have moles of strontium chlorate, we need moles of the other thing we're seeking. Now what we're looking for, we're not looking for the other reactant in this case. That's what we did up here earlier. What we're seeking now is the product in this equation. And the product, according to the way the problem's written here, is whatever the solid is. And when we balanced the equation and predicted the products, we found that this is the solid here, strontium sulfate. Okay? So we're going to have a molar ratio that goes from our starting amount, strontium chlorate, to the amount of strontium sulfate. And that's a 1-to-1 molar ratio. You've got coefficients, implied coefficients of 1 and 1 here and here. So if there were other coefficients, we'd use something else. But in this case, we're going to say 1 mole of strontium, I don't need that yet, strontium chlorate, okay, and 1 mole of strontium sulfate, okay, and we're ready to cancel units and species. So I got units of moles on the top and bottom, and species of strontium chlorate top and bottom, okay. Now that we've reached the point where we have moles of strontium sulfate, I need to have this is actually an amount. Technically this is an SI unit for the amount of substance. But we can't measure moles. We have to put it in grams or volume or something to be able to measure it. So we're going to change that into mass. And besides, in order to do a percent yield, since we have this amount of solid collected in our problem, 2.95 grams, we've got to convert this to grams in order to do a percent yield. Okay? So I have to have another ratio here. And for that, then we're going to have to calculate another molar mass. We have not already calculated the molar mass of strontium sulfate. We need to do that. So strontium and sulfur and oxygen. We've already looked those up. We have strontium is 87.62. And sulfur we looked up here, 32.065. And oxygen we know is 15.9994. And in the formula we have 1 strontium and 1 sulfur and 4 oxygen. So we need to multiply this by 1, and this by 1, and this by 4. .9976, and you can see then that there are empty slots in these positions here. So when we add it up, we need to round off so that we get rid of any digits that are resulting from those empty slots. .183.6826, and these two digits get rounded off because of the empty slots above them. 183.68 grams of strontium sulfate equals 1 mole of strontium sulfate. Okay, so this is our molar mass for strontium sulfate, but in order to have the equality statement that you need for a conversion unit up here, you are required in this class to always write this equality statement at this point. This many grams of this equals 1 mole of that. Okay? So now we have what we need to write the the molar mass ratio, the conversion unit up here. I want to match the species down here with the species in the previous step. So I need 1 mole on the bottom, 1 mole of strontium sulfate. And I'm going to put the mass on the top, 183.68 grams of strontium sulfate. Okay, cancel units and species. All right. And we can do the math now to find the amount of theoretical yield. Now, before I go further here, let's just point out one little thing that I think is kind of neat. All right. Notice that every time you do one of these conversion steps, either you have the same species in the top and bottom, or you have the same units in the top and bottom, but never both. That makes sense? So this molar ratio, which is not a unit, it is a conversion factor, but not a unit, because it doesn't equal 1. It has the same units in top and bottom. Okay? This one has the same species top and bottom. All right? So you can only convert between units or species one step at a time. All right? Just a little thing to kind of help you check if it might be something that will help you on a test. All right, so we're ready to do the math now. As far as this, we're going to multiply everything across the top. Don't have to multiply by 1 because it gives you the same answer if you do. So 5 times 183.68. Okay? And then what we're going to do is we're going to divide separately by anything on the bottom. Well, in this case, we've only got one thing on the bottom. So we're going to divide by 254.52. Okay? And we get this great big old long number, 3.60836086. Looks like we got some numbers that are going to repeat.
Wow.
Okay? All right, so we want to look up here in our problem and see how many significant digits we need in the final answer. We only consider measured numbers like this or calculated numbers like these, not the counting numbers like these ones. Okay? And so this one has the least number of digits, and so that's what we need in our final answer. We only need 3 significant digits in the final answer. We only have 3 significant digits. So I'm going to underline everything after the first 3 significant digits. And I haven't put the units and species down here. I need to do that. Grams of strontium sulfate. Okay? And then we need an arrow to show that what we have as the next step is a rounded answer. It's not equal. Okay? 3.61 is not equal to that number. It may be ever so slightly different in your mind, but that's not equal, so you can't say it's equal. Okay? And that's grams of strontium sulfate. Okay? And that's the answer we want at this stage anyway. So this now is the theoretical yield. Okay? That's our theoretical yield. Okay?